I want to try and convince you that neither the mass nor the radius really affects the time it takes to get to the bottom of a ramp. So you've seen that two objects of equal radius but different shapes will reach the bottom of the ramp in a different amount of time. The one that puts the greater percentage of its weight on the perimeter has a higher rotational inertia, and therefore the bulk of the energy it starts with gets spent on rotation and less of it is available for translation. And so the one with the larger rotational inertia calculation has the greater amount of time to reach the bottom of the ramp. So we can try it again. Two objects of the same radius. The one that has the larger rotational inertia is going to spend more time, is going to translate slower. The one with the smaller rotational inertia is going to translate faster. Set them side by side, let them go, and you can see the result. But more importantly, I want to show you that it's really only the shape that matters. This one has a bigger radius and a bigger mass. This one, less mass, less radius. But mass and radius really aren't part of the equation in determining which one's going to win the race. It's just the shape. And so hollow cylinders roll side by side. Two solid cylinders roll side by side. It's just the shape. How about two different solid spheres? Side by side. There's a hollow sphere. There's my solid sphere. Make your prediction. That's absolutely right. Because the hollow sphere puts all of its or most of its mass farther from the axis of rotation. It has a greater rotational inertia and therefore translates more slowly down the ramp. So with all of that in mind, I want to ask you this challenge question. What happens when I race a can of chicken broth versus a can of cream of chicken? So this is all solid, whereas this material is filled with liquid. And the liquid doesn't rotate. It's the same sort of thing when you drink a beverage out of a glass and maybe you have just one ice cube in the glass and it keeps hitting you in your teeth as you drink it. And so nobody drinks a can of chicken broth, but imagine this is a glass full of something I want to drink and there's an ice cube that keeps hitting my teeth. Then I don't want to put my dirty fingers in my drink and move the ice cube out of the way, so I try to take my drink and turn it, but I find the ice cube still stays in the same place because of its inertia. In other words, the glass rotates, but the liquid stays in place. That's the same thing that happens with a can of chicken broth. The can rotates, but the liquid doesn't really rotate. The liquid just translates. So maybe I've given too much away, but make your prediction. Cream of chicken, where all of it rotates, versus chicken broth, where only the can rotates. Ready, set, write down your prediction on a piece of paper and give an explanation of why you think the broth wins or why you think the cream of wins. Whichever one you think wins, make your prediction and give an explanation why.